Hi, I'm Scott Hunter, and I am super excited to be at the .NET Summit 2020. Thanks for having me. I'm here today to talk about the journey to one.NET. For folks that don't know me, I'm the Director of Program Management at Microsoft on the .NET platform. I've been here since 2007, started with ASP.NET, and now work on the entire platform. You can follow me at @CoolCSH on Twitter if you want. Let's jump right on in. So for .NET, when I joined back in 2007, we built .NET Framework, and it was primarily used for building desktop and web applications on the Windows operating system. Since then, .NET has grown in leaps and bounds. With .NET Core, with Xamarin, we now have added cloud workloads, mobile workloads, gaming, IoT, AI. I like to say anything you want to build, you can build it with .NET. Our ecosystem has really had some great momentum as of late. We shipped the first version of .NET Core with tooling in March of 2017, so it's about a little over 3 years ago. Since then, we've added 1.5 million .NET Core developers to our platform using Visual Studio. In Stack Overflow's developer survey that runs every year, .NET Core has been the #1 most loved framework for both 2019 and 2020. And then in GitHub, we open sourced .NET in 2014. And since then, we've actually jumped into the top 30 highest velocity OSS projects. That's the amount of activity and stuff going on in those projects. All up, GitHub's a big space. C# is the #5 language. We've had a huge amount of work we've done on performance in .NET over the last couple of years since .NET Core started. That being one of the reasons we tell customers to use .NET is it's faster than any other tech. There's a plain text benchmark in Tech Empower, and we're consistently in the top part of that benchmark in the top 10. And that puts us like 7 times faster than Node.js. We're faster than Java. And so we're continuing to work on these benchmarks, as you're going to see in slides later on, doing well in the data benchmark called Fortunes and the JSON serialization benchmark. So my message there is if you want a fast framework, that's that for you. And, of our growth, a good chunk of the growth is students. It's great to see people learning to program for the first time using .NET. Makes me very happy. Adoption. In the Visual Studio family, using one of our Visual Studio IDEs, we have over 5 million .NET developers. And what's cool about that is in the last year, 2019, we added 1 million brand new developers. 600,000 of those developers are .NET Core developers. And then, as I mentioned before, or haven't mentioned yet maybe, is .NET Core is, it's cross-platform. It runs on Windows, Mac, and Linux. Just in the last couple of months of 2019, we were seeing monthly numbers of 2 million publishes to Linux. And that excites us that people are taking advantage of these new platforms we've added to the family. .NET Core 3, we shipped this in September of 2019, and it's the fastest adopted version of .NET ever, meaning that most of the time, it takes a customer a couple of years to move to a new version. But .NET Core is side by side, meaning you can install multiples on the machine without affecting each other. So I might have a machine with 2.1, 3.0, 3.1, 5.0 preview. And because of that side by sideness, you can try things right away. 75% of our developers in the first 6 weeks already had tried .NET Core 3. And so I love the fact that developers are staying on the bleeding edge of the innovation that we're providing in the .NET platform. Today, what we're going to do is we're going to talk briefly about what's new in .NET Core 3.1, and then we're going to delve into what's coming in .NET 5 and beyond with some cool demos as well. So let's do a quick recap. We just shipped at Build in May of 2019 Blazor WebAssembly. We'd already shipped Blazor with .NET Core 3 and 3.1 with server-side Blazor, and that's where you still write code in your markup file, and it appears to run in the browser. But with Blazor WebAssembly, it actually does run in the browser. So we call this full stack web development. You can build the back end, the front end, even where you would write JavaScript, you just write C#, because we can run C# natively in the browser using WebAssembly, which is a technology that lets you run many languages inside the browser. Because we can run the C# in the browser, it enables brand new scenarios like progressive web applications or PWAs. PWA is an app that is a regular web app that can be installed as a desktop application. And one of the things that makes PWAs interesting is because the C# code is running in the browser, you can have full offline support because the C# code is all running there. It doesn't need a server. It can still talk to a server and sync up when the server is there, but it doesn't have to. It is now included with the 3.1 SDKs since May of this year. So with that said, let's quickly jump in and I can show a little bit of Blazor real fast. The first thing I want to do on Blazor is just kind of show, here's the Blazor template inside of Visual Studio. I can select next. We'll just call it Blazor there. And this is where things kind of get differently. You see there's a Blazor server and a Blazor WebAssembly. I still recommend Blazor server for most cases. If you create a SPA application with Blazor server, you're going to get it's going to be one of the smallest SPA apps ever, because we don't have to bring down an Angular or a React or a Vue or a JavaScript framework to the browser. It's just your native app and a small amount of JavaScript to talk to our server. But there's now Blazor WebAssembly, and with that, notice that down here there's a new checkbox for progressive web applications. Now, I'm not going to create a new one right now. I'm going to close this out actually. And what we'll do is we'll switch to a app that already has Blazor inside of it. So I'll quickly run this. This is a Blazor WASM app, so it's actually running in WebAssembly. And I'll launch it here. And it's a SPA, so it's going to say loading while it's getting ready. And you can notice I click around, it's instantaneous. It's not doing postbacks. It's pretty nifty. Now, what I want to do now is I want to show that, as I said before, it's full stack development. So remember, this code is going to run in the client. It's going to run in the browser, not on the server. And I've got breakpoints before we make the call to get the weather and after we get the weather. And then over here, I've got a breakpoint set in the API in my server. See, there's a server project here and a client project. So I'm going to press F5. And what's cool about this is we have the ability to do debugging across the boundaries. You can put breakpoints in the client, you can put breakpoints in the server, and we do all the right magic to make that work, which I think is pretty cool. So wait for the app to load here. There we go. And once again, it's the same app you saw before. I can click around, there's no page refreshes. If I go to fetch data, look at that, breakpoint just hit. And you can actually look down here. We run Blazor WebAssembly using the Mono framework, and you can see Mono here. So you can see it actually is running a different framework that's actually inside the browser. You can see the WASM there. I can press F5. Now we switch to the server. If I bring the Solution Explorer over here, this page is in the server. This is my web API up here at the very top. You can see it's a controller base, returns an enumerable, that returns my data. I press F5 again. I'm back in the client. And I'll continue to run the application, and that shows this app can run both client server, and you can do debugging across those boundaries. Now, I mentioned before there was something called progressive web applications. Because I've got that enabled for this project, there's this new plus sign up here in the browser, install Blazor. I can click that button and it asks me if I want to install it. There you go. Notice the app just changed. It went from being running in my browser to running with kind of a desktop shell there. If I go to my start menu, here's the app right up here at the top of the screen. I can even do cooler stuff. We can go up here and let's go run the start menu again, and I'll click uninstall. And there you see my app is actually looks like it's a desktop application there. And that's just showing the cool aspects of Blazor WASM. Okay, so let's turn that project off here. There we go. And we'll go back to slides. Okay. So the next thing that we've done is, as I mentioned before, we shipped WinForms and WPF with .NET Core 3. And it's been quite a journey to port the designer. Visual Studio actually runs, on top of .NET Framework, and you really can't load two .NETs in the same process. And so we had to actually take the web form designer and make a new version that runs out of process so it can run on top of .NET Core. And with the current versions of Visual Studio as of today, you're going to find all the controls you would expect to be in the toolbox that can be dragged and dropped over into the forms. The next big thing for us from a designer standpoint is we need to add support for third-party tools so we can get the controls from all of our partners into the product. And that'll happen soon as well. Something else that's pretty exciting in the .NET 3 space, the .NET Core 3 space, is ML.NET. We shipped ML.NET a little over a year ago. And it is a machine learning library that we used inside of Microsoft for many of our products. If you sign into your laptop with Windows Hello, or you use PowerPoint and it recommends styles, that's ML.NET. And so we built it because we wanted .NET developers to be able to stay in .NET as they added machine learning to their projects. But we took it a step up. We have a new feature called Model Builder. It's in Visual Studio as well, but you have to drop the Tools menu, go to Options. There'll be a preview section in there. You can check a checkbox, restart Visual Studio, and you'll have Model Builder. Model Builder lets you just add ML.NET to any .NET project. What you do is you right-click on the project. Under the Add submenu, there'll be machine learning. You click that. This wizard that you see on the screen will come up. You choose the machine learning workload that you want. It will then ask you a couple of questions. I need some data. Which column do you want us to predict? And then we'll do all the hard work for you. We'll try all the algorithms we support. We'll find the best one. Once we find it, we'll then take the data you gave us and we'll make a model, a machine learning model for you based on that data. And we'll put that in a side project. We'll also inject some code into that side project to make it very easy to call to get the predictions from the machine learning code. So literally, you can probably go from 0 to having a running app in 10 or 15 minutes with Model Builder. Super excited about it. Try it out. Give us feedback, please. Next is, kind of where we're at today. .NET Core 3.1 is our long-term support release. That means it shipped in December of 2019, which means it has 3 years of support before you have to move to the next version. So you can stay on this for a long time. It's got WinForms WPF. It's got side-by-side support, meaning you can have more than one version on the machine. If you want, you can make an app that doesn't require .NET on the machine at all. You check a box, and we will make you a self-contained exe that contains the framework in your application. And you can copy that to a machine with no .NET on it at all. And I'm going to demo a little bit of that in a little bit. We've got modern web UI with ASP.NET Blazor. And we have some new C# features as well. So it's a great release. If you're building a new .NET app, this is what you should use. Now, let's kind of talk about why we're here. I kind of like to laugh. We made lots of .NETs at Microsoft, and I have to apologize. I made one of them as well. .NET Framework, that shipped in 2002. That was the initial version of .NET, and it supported Windows applications, whether they were desktop or web. But it was tied to Windows. I mean, it's a part of the Windows operating system. The two are coupled. So in 2014, we started thinking on the ASP.NET team, what's the next generation of ASP.NET? And we knew we had to kind of get .NET into a new place. And so we created something called .NET Core, which is a brand new, smaller version of .NET. It only has the APIs that we think you would use today if you're building a brand new app. So instead of having WCF, it's going to have something called gRPC. Instead of having web forms, it's going to have Blazor. In many cases, there's a replacement of what you would use if you're building a brand new app today. .NET Core is fully open source. All the code is on GitHub. .NET Core is cross-platform. It runs on Windows, Mac, and Linux. It supports the x86, x64 architectures on Intel. It supports ARM64 and ARM32, so you can run it in all kinds of places. And then there's Mono, which powers our Xamarin technology for building mobile apps in .NET. You can build apps that run on iOS and Android. But what we want to do is we want to simplify this and get this back to something that looks kind of like this, a single platform. You download one SDK, the .NET SDK, and from that you can build mobile, web, desktop, console. We want to have one BCL. That's the base class libraries. That's all the APIs that you call to open a networking port like HP client. And crazily enough, there's different implementations of those in all three of those boxes before. And so in the .NET 5 and 6 wave, we're going to get down to one implementation. So your apps are super consistent. .NET Core brought a new tool chain that had a simplified project file that you could hand edit and a command line interface if you wanted to actually skip an IDE and just build from command line. Everything will be built on top of that. We're going to have awesome cross-platform native UI with the Xamarin technologies that are merged in. We're going to have awesome cross-platform web UI with the ASP.NET technologies, including Blazor that we just did a quick demo of a second ago. And we have some awesome investments in cloud native. You might say, what is cloud native? Think containers, Docker, Kubernetes, microservices, all those words. That's what cloud native is about. And then, of course, we're always making it faster, smaller, more diagnosable. And we think that at the end of this wave, we'll be the best breed. We'll have the best breed solutions for all those platforms, all those workloads I mentioned earlier on .NET. Let's talk about some of the perf improvements. I mentioned perf earlier. We're, of course, always making .NET faster. So if you're running on Linux, you're going to see a 30% performance improvement on sockets on .NET 5. All of us are using JSON serialization to call and make APIs. 20% improvement in JSON serialization performance in .NET 5 over 3.1. Serialization of large object and arrays 3 times faster and now zero alloc. Less memory, higher performance. And then gRPC, which is an awesome way of building contract-based APIs. You can see here on the left side, it talks about client performance. That's calling into a gRPC service. You can see that we are faster than Go by 2 or 3 times. On the right side, we're showing server performance, and you can see we're slightly ahead of Go. But once again, that's my point earlier, is we are awesome at performance in .NET, and we'll continue to work on this as we move forward. So let's talk about cloud native investment. There's a whole bunch of things here. We want to be the best tech for building REST APIs using web APIs. We support the Open API spec. This is a definition of your API in textual format. And because of that, we can actually do what we call, we have a REPL. You can install it, and then you can F5 directly into the REPL, which means when you run your API, you don't get an error that there's no web page there. You get a REPL, which you can then do a dir command to find the APIs. You can actually run the API right from the REPL. You can even do a breakpoint in VS from that. And so we're giving you a great interloop experience. Client generation. From that same Open API spec, we can actually generate the client code. So you build a nice REST API, and you don't want to write the code to call it. You can right-click, add a client, and easily call that API. As that Open API spec updates, the client API will change on the fly as well. And we have awesome support for Azure here. You can take an API, publish it to Azure, and once it's in Azure, you can even hide it behind Azure API management if you want to manage it for security and monitoring and stuff like that. I mentioned gRPC already. That's great for building contract-based APIs, and we're doing the same things for that we did for REST. You can write that, it's called a proto file. It's the definition of your API. These APIs are cross-platform. You can call it from Java, Node, whatever. We'll actually call it from Java, Python, or Go. We can also generate the client for you as well from that same proto file. We can generate the client code, so it's super good tooling and world-class performance. What if you want to build your applications on your machine and you want to run them on Linux? I'm going to show you in a second how easy it is to do that. People want small microservices. We've done a lot of work to reduce the amount of code you have to write to build a microservice. You can make it into a single file, a single exe, and we can make it very small. And of course, finally, as you think of microservices, how do you host and run these things locally? I'm going to show you Project Tye, which is an awesome way of doing that. So let's get into show, well, one more slide. There's also C#9 as part of .NET 5, and it's got 2 features that I highlighted here. One is records. It lets you actually define a class in 1 line of code. And the second one is top-level programs, which notice here there is no main or any ceremony there. You just write your code. And with that, let's do a couple of demos. So what I'm going to do first is I'm going to go and find this app. And this is just a Razor page application, and I've got the main page open here, and all it does is has a little bit of C# here to write the version of the OS out to the screen. So let's run this and see what happens. And it's going to do exactly what you expect, I think, and that is we're going to launch, and it's going to write out and tell you that, hey, we're running on Windows, because we are. Now I'm going to close that out. I'm going to take the drop down, and I'm going to select WSL2. That's Windows Subsystem for Linux version 2. All I do is click that, and now I can control F5 again. And because we're running on Linux, what's going to happen is my Kestrel is going to launch here. There it goes. My browser opens up, and voila, my language or my OS is now Unix. So that's simple. I'm now running on Linux. I'm going to run it one more time just to show you that once it warms up, it's really fast. Boom. There we go. I'm running on Linux. And not only can we run on Linux from that perspective, I can also put a breakpoint right here, and the debugger works through Linux. So basically, we're giving you the exact same experience that you would expect from our toolchain on Linux on top of Windows. There you go. The breakpoint runs. I can hover my mouse over it. It says Unix 4.19.104.0. So you can see it's actually debugging in the Linux. There I am. Close that out. I want to say one more thing here. I can also take this project and I can right-click on it. And maybe in my organization, we are using Docker. I can click over here and say Add Docker Support. It's going to offer me Windows and Linux. I'm going to choose Linux in this case. And all it's going to do, we've really worked on this over the years to reduce the amount of changes we make to your project. All we do is we add a Docker file. I can open that Docker file, and you can see that it basically pulls down an image of ASP.NET running in a container. It also pulls down an SDK. And that's because what this app does is it actually takes one container to build another container. So it uses the SDK to build a container that does not contain the SDK, so we can make the container as small as possible, and then has it ready to run. And you can notice that my drop-down now says Docker, and if I run the application, it's going to say Linux still. Let's give it a chance here. It was pretty nifty. While I was showing you the Docker file, it was actually booting the system up in the background. There you go. We're there. If I came over here and opened up a terminal, I could say Docker ps-a, and there you go. You can see my app running in Docker. That simple. And so we're making it awesome to build your .NET apps and run them wherever you want, all on your Windows machine. So let me close that out. And I think the next thing we're going to show is a little bit of C#9. So this is that top level feature, the top level program feature I was mentioning before. This is my entire app, program.cs, and it's got one line of code in it. There is no main, none of that stuff. I just want to get to my code. I can take this app and run it. It obviously just says hello world. It's not super fancy, but I'm going to go to the CS proj file, and I'm going to switch us to the web SDK. There we go. And it's going to ask to reload the project because I changed the CS proj SDK. And now what I'll do is I'm just going to go take this and we'll wipe that out. I stuck some other code down here, and this is a microservice written in .NET. And notice, even with the usings, the entire program is 15 lines of code. It literally is a 10-line microservice in .NET using top-level programs to remove more of the ceremony. And this runs too. There you go. The browser pops up. Hello world. So hello world in that size application. Now let's take that to the next level. I'm going to close out, and I've got one more version of the same app, same 10 lines of code. But what I'm going to do this time is I want to talk about single file. So I'm going to go to a command prompt here, and we'll come back over here, and I'm going to run a publish command on the tech. And this is .NET publish. And because I'm going to build a single exe, I need to tell it what architecture, because one file can only contain one architecture. So I'm going to say WinX64. I want to release build, and then notice I say publish single file equals true. And this is that feature I mentioned earlier. You can take a WinForm application and use this, and your app no longer requires .NET to be on the machine. Because if I go look at my folder here, it is a little large, and I'm gonna talk about it. There's a 71 meg app. I mean, it's large, not terribly large. That app is basically my ASP.NET app and a copy of the entire .NET Core platform, all stuck into a single exe. We can do better than that, and I'm still showing a preview of this tech. It'll get a little better before we actually release. Let me do this. There we go. And notice all I've done is I've taken that same publish released to WinX64, publish single file equals true, and I've added this, publish trimmed equals true. With publish trimmed equals true, what we do is we'll actually go and remove any of .NET that we don't think your application is using. And that's where this is some tricky tech. Sometimes it's hard for us to know what you're using. And so it does have some risk applied to it. But we're gonna get better at providing tools to make it easy to figure that out. I'm gonna run this again. There we go. In fact, it tells you optimizing assemblies for size, which may change the behavior of the app. Let's say you're using reflection to call something. We don't know that, and you'll have to tell us not to link that away. Now, if I go back over here and take a look now, we were 71 megs before. Now we're 29 megs. And I'm on a kind of preview release. I just did this over the weekend on the next preview, and it was basically 20 megs. So we went from 70 to 20. We trimmed out 50 megs of code, and the team thinks we can go even further. And so I'm super excited about the progress that we can make here. Okay, so let's close that out. And now I want to talk about microservices and Project Tye. And so over here, I've got an app, and let's do a dir here. You can see I've got a front end and a back end. .NET is great at running a single application. We're not great at running multiples. And as you start building microservice, containerized applications, you might have a web front end, you might have 2 back ends. What can we do to make that easier? Right now, what I would do is I would go into my front end app, and I might do something like .NET Run. And then once that comes up, I might go and launch my browser and try to hit that. You might guess what's going to happen here. This isn't going to go well. Also note there's a port there, localhost 44367. Where are you going to stick that? You need to be able to tell front end and back ends where to actually get that data. And so this is going to basically crash because I didn't start the back end. Now notice in my terminal here, I did have a prompt open in the terminal for the back side of the app too. I'm just going to close it out. We're going to use Project Tye. So let's close the app out. Let's go up a level, and I'm going to run Tye run. And this is where it gets very different. And we'll build this experience both in Visual Studio and from the command line. What happened here is Tye went out and found all my projects and ran them all. And it gave me a dashboard. So let's launch that dashboard. So here's this dashboard. Normally when you run a .NET application, it just runs the app. This dashboard is super useful. Notice here, I now have access to the logs for the front end app and the logs for the back end app. It's pretty tricky. I've got this on this side. I can click each of these, and now I have the perf counters for this app. So as this app is running, I can go click these and see the data. That's a lot more context than I ever gave you before. And notice that we also gave you both the HTTP and HTTP addresses for both the front end and the back end. So it's very easy to click one of these to run the apps. Now I'm going to click that, and guess what? It's not going to run still. I know this already. Let's close it out. Let's fix that. And I'm going to show you a pretty cool thing here. So let's do VS Code. And I've got my front end, my back end. And the main thing that we care about here is, as I look at this code, let's scroll up here. Notice that this is my front end application, and it has to call the back end service. And so what we did here is we hard coded the URI, the local host, and a port. Well, that port could change. When I publish the app to the cloud, that port's going to change. That's a bad idea. So let's go to our project file, and I've got some things I can just uncomment here. I'm going to uncomment that. And this includes a new package. This will be built in by the time we're done. And Microsoft Tye extensions configuration. And so what I can do now is I can go back to my startup. And instead of having a hard-coded URI, I can comment that out. And I'm going to comment this new code in, which says configuration get service URI, and it just gives it the name of the project. Because what's going to happen is Tye is going to go figure out a random port. It's going to inject that into the process and put environment variables in all the running processes with all the ports. And so all you have to know is the name of the project, and we'll do all the port mapping for you. So if I save that, I can go back to the command prompt, and I can do a Tye run. And now I'll have a fully functional app again. There we go. Refresh the dashboard, and there we go. We have an app. Now, we talked about services and containers and stuff like that. Let's make this app a little more complicated. What if you wanted to add a SQL server, or you wanted to add a Redis cache, or a Postgres, or a MySQL? Well, Tye supports containers. It doesn't require you to know how to write Docker files. We'll do that for you. All I've got to do is say Tye init on the command line, and it writes this Tye.yaml file. I can go back to my VS Code, and there's the Tye.yaml file. And this contains, you can see it contains all the things that Tye discovered. It found both those CS Proj files, and so it says, hey, you have two services, a front end and a back end. I'm going to go and grab some text I stuck in a notepad here. Oops. And I'm going to add a new service. Now, what this does is notice these first two, and I'll zoom this in a little bit. These first two basically say the name of them, and then there's a project, which means it points to a CS Proj file. In this case, I'm going to name this one Redis, which means that's how I would point to the URI. But instead of pointing to a project, I'm going to say I'm going to point to an image. That means a container. So I'm going to point to the Redis container in the container registry. I'm going to give it a port and a connection string. And then I actually going to run another image of Redis. And in this case, I'm running a CLI telling it to be a monitor. So the first one is the actual Redis server, and the second one is the server being run again to be a monitor for the first one. And I'm going to save that. And so we should be ready to run. Let's make one more change to our app. Let me go back to my CS Proj file, and I'm going to add another package. And this is the package for Redis cache. So this enables a .NET project. You can see Redis caching, Stack Exchange Redis. That's a NuGet package for running caches. And then I'm going to go to my index.cs.html file. Now that I've got a Redis, actually I'm going too fast. Let me slow down. Let's go to startup CS. Now that I've added that package, I need to add the cache in using dependency injection. There it is. So a couple lines to add that to my app, and then I can go into my CS Proj, or not CS, my index.cs.html, and I can uncomment this tag helper. This tag helper is a tag helper that we wrote for .NET Core, and what it does is it lets you basically cache the contents inside of the tag helper for a time of your choosing. In this case, you see we did 5 seconds, and so now if I go back and I do a Tye run again, a bunch of stuff's going to happen. You can see there's more activity here as it boots stuff up. Wow, that's a lot of stuff. Let's go back to the browser. Let's refresh the dashboard. And now something new happened here. Notice that I've got 2 CS projects like we saw before, but now there's 2 containers. And that's because those image tags told us to run containers automatically. I get the same kinds of features. I can go look at the logs for these things. But now if I go and run that front-end application, if I keep refreshing the screen here with F5, notice the numbers don't change except every 5 seconds. And that's because we're caching that stuff. I can go back to my dashboard, go view that Redis log, and you can see all the cache hits happening here in the log file. Now, to me, this is pretty amazing. I could take this project, I could give it to any of you, and as long as you have Docker installed in your machine, you don't have to worry about having Redis or SQL or whatnot. We'll just bring the containers down automatically. One of the final things I'll show on Tye is one more command. I can do Tye run --help, and notice there's a command here called --docker. Now, in my real production world, I'm going to run all my apps inside of containers, and I want to test it locally and make sure it works great. So I can just run it again and pass --container. Now, I didn't have to write a Docker file or know any stuff about that. All I do is tell Tye to run all my apps in containers. Oops. I'm obviously mistyping container Docker. Okay. And so this is going to boot Tye up one more time. And when it does, it's actually going to run the entire app inside of containers. So now I'm running exactly like I would run in production. I can go back to my dashboard. I can refresh. And now notice that these things that before said project, they now say container. The entire app is running in containers on my local machine. I run it. It runs exactly the way it ran before, showing you how easy you can build a multi-project application in .NET. It can include services like SQL Server, Redis, Postgres, whatever there's a container for out there. And then you can run the entire application inside of containers. I didn't show there's a watch command, so you can actually keep the app running and make changes, and it'll refresh on the fly. And there's even a deploy command where I could basically say Tye deploy. I'm not going to let it finish, but it would actually take all my containers, put them up in a container registry, and the entire app could run in the cloud. Super, super, super exciting tech. I think it's going to be amazing, and I look forward to hearing your feedback on using it. Now let's get into cross-platform native apps. Today, we build these using Xamarin. And we wanted to make Xamarin feel like it was more part of .NET. And so we're going to rebrand Xamarin a little bit and call it .NET Multi-Platform App UI, or abbreviated to .NET MAUI. And the premise here is basically this. It's cross-platform native UI, runs natively on iOS and Android. It has a single project. If you use Xamarin today, it actually has an Android project, an iOS project, and some shared code. Now that's all into a single project, and so it makes your life easier as a developer. Single code base for all the apps on all the platforms. You can right-click on the app and deploy to mobile and/or desktop. It's an evolution of Xamarin Forms. If you've come from Xamarin Forms, this should make you feel comfortable. It's the same tech, rebranded and put directly into the SDK and a part of .NET. It's going to target the .NET 6 release next year. But we hope to have previews of this probably in the October timeframe after we open up the branches for .NET 6. So how does this look? From a namespace perspective, we're going to basically rename space this tag to system.ui and system.devices. File new, you'll get your multi-platform app UI. And from the CLI, there's a .NET new MAUI. For the iOS and Android projects, they're now going to be called just .NET for iOS and .NET for Android. Very simple, part of the .NET family. You can build them from CLI as well. .NET new iOS, .NET new Android. Should be what you expect. And so let's do a quick demo or two of that. So here I'm going to switch to my Mac. And in my Mac, I'm going to make a directory called MAUI. And inside of that, I'll jump in. And now I'm going to basically type .NET new MAUI. Because this is part of the .NET SDK. I'm on a preview build here, so it's still got the multi-project stuff, but we'll get that cleaned up. I do have to run a NuGet restore to get my dependencies. But after this runs, I'm basically going to go and run VS Code. Do code dot, there we go. And here we are in VS Code. And let me drill into my project here, and I'm going to go to that main page.cs. And this is probably surprising. Notice there's no XAML here. This is actually showing a new way of building UI, where you can actually write your UI directly in C#. You can see I've got my state, I've got my body, it's got VStack. Now let's run this, because it gets better. I'm going to run this, select my iOS version. I'm going to open up the iOS emulator on my Mac. And in just a second here, we're going to see an icon appear on the iPhone. There it goes. Looks like it's built. It's going to deploy the app to the phone. You can see the icon installing. There's my bot. I'm going to run this. And I've got a running application on an iPhone on my Mac. Now, what's cool here is I'm going to show hot reload and hot restart. And so all I've got to do here is take this code and let's fix some of the issues. Like that left alignment I don't like. Let's make it in the center. There we go. It's in the center. What if you don't like the color? And the big thing to think about here is notice how fast after I change the code, the app updates on the right side almost instantaneously. Not a fan of pink. We'll go back to black. And so I'm just changing a few properties here. I can also change the code. I can come down here to that value. Let's make it -. So the button now is going to make us go backwards, not forwards. Let's click it. Value decrements right away. I can fix the UI there as well. Change the plus to a minus. And you can see how easy it is to build a .NET MAUI app on an iPhone with a Mac. Let's switch back to VS and show the same thing. Here I am in VS, and I've got a .NET multi-platform app UI template. I'm going to minimize and open a project I've already created. And so if you were freaking out before when you saw that that C#, I want to appease everybody and let you know we're not getting rid of XAML. We just know that some developers prefer that more native-y kind of markup style that you can get with writing native code. But we're always here to support the XAML tech. And so here's the exact same layout running in XAML just like you would expect. So with this, I want to show a new feature. Notice that I'm going to run this application, and I don't want to have to emulate on a device or hook a device to the computer, so I'm just going to run on Windows. And here's my same exact .NET MAUI application running right here. You can see the debugger on the right side. I click the plus box. It does what you would expect. It's basically the same app. I can resize it because it's a desktop app outside of the size of a phone, and you're good to go. So let's stop that, and I want to talk about another feature that's actually in the existing Xamarin Tech today, and you can use right now. And this is hot reload and hot restart. This enables me to basically take my iPhone, and I'm going to plug it into the side of my Windows PC. Even though I showed a Mac, I cheated a little bit. I showed a video. Today I'm actually running on a Windows PC. I don't have a Mac near me. But notice that my iPhone just showed right up here, Scott's iPhone. So all I did is plug the cable in and went to my VS, and now I can right-click and deploy directly to my iPhone. I'm running a program called Reflector here, and it basically lets me mirror my iPhone to the screen. And notice how fast that was. It wasn't just a few seconds before I was able to bring this up and run the app just as it was before. And this is super cool. I said the ability to plug your phone in and just start developing, that exists today, and please use it with the existing Xamarin Tech. I think it's going to change the way the world works. Now, let's think about the project for a second. If you go and look on the right side of the screen, I've got some new nodes. First off, this is a Xamarin project, or now a .NET MAUI project, and it doesn't have an Android project, a Windows project, an iOS project, and a class library. It's just one single project. In this resource node that I just opened up, that's where all my resources, fonts, images, and stuff like that I want to use across my application, I store them all in one place versus storing them across the different platforms. Here's some fonts I've got here. So I got 3 fonts. I've got an image. Pretty cool. Even cooler is there's another node up there as well called platforms. We know that when you're building apps that run on multiple devices, you need to write source code for those particular devices. So now there's an indicator for each of the platforms, Android, iOS, and Windows. I can open those up, and when I do, you're going to see basically, hey, each of those has a different way of talking to Bluetooth. And so I've got a different implementation of Bluetooth for each of those. When I build the app for iOS, it's going to use that version of the Bluetooth adapter for that application to make that work. And so I think this is going to dramatically make building these types of projects better, and I'm super excited about it. So that's .NET MAUI. So .NET 5, it's going to ship in November. It's going to bring a lot of those cloud-native improvements that I showed. There's a preview of Project Tye out today. It'll probably ship in .NET 6, but it's completely usable right now. What you'll see us do is actually integrate it directly inside of Visual Studio and the rest of our tools as well. And then there'll be previews of .NET MAUI out pretty soon. Preview 7 of .NET 5 is out right now, and you can grab it. I do want to talk about our release schedules. It used to be that we shipped .NET at random periods of time, and it was hard to figure out when the support ended for a version of .NET. And so we're going to be very, very open moving forward. We ship every November. So .NET 5 is going to ship this November, .NET 6 next November, .NET 7 the next November. Now there's something different about these. Notice that some of these are LTS and some of these are not. LTS stands for long-term support. If you're on an LTS release like .NET Core 3.1, you will have 3 years before you have to move to .NET 6. So when .NET 6 ships in 2021, you will have until 2022 to move to it. So if you want to stay on the slower pace and stay on a release for a longer period of time, stay on an LTS. If you want to be on their fast releases and always be on the current release, you can stay on the newest release all the way through this. We actually cloned this from other open source projects like Node and Ubuntu follow a similar model. Java does too. But the hope is it's predictable and easy to understand. I need to call out something else. November 10th will be the launch date for .NET 5. And we're going to have our own virtual event for 3 days there. It'll be half Microsoft employees and half community, all talking about all of .NET. You can go to the website now, put it on your calendar, and please come attend. My final going away notes are, if you're building new apps, really think of .NET Core 3.1 as your solution. It's awesome. It's got all the latest stuff in it. If you want to go try the new release, because they're side by side, you can put .NET 5 on with no risk of breaking your 3 or your 2 apps. And then I finally should go out and say, if you have apps on .NET Framework, there is no rush to move them to .NET Core or any of this stuff. .NET Framework will remain to be supported. We still patch it every month. We work on it for perf, security, and bugs. And so there's no risk of that going away. So it feels safe to leave those apps there. Build new apps on this tech. And with that, thank you so much for joining. Thanks for having me at the conference, and I would love to come back in person in the future. Thank you.